Hi, this is Riddhi, and this is my video assignment for question number one. Okay, so the question is we have to integrate this term x under root x cube plus 1 first with respect to dx, and the limits are from under root y to 1, and then with respect to dy with the limits from 0 to 1. Now moving to step 1, which is changing order of integration. Here I have assumed this is the term dx dy. I have assumed the limits under root y and 1 to be equal to x, and here the limits with respect to dy, which was 0 from 0 to 1 to be equal to y, and I've plotted the graph of these limits, which will be useful for us in the next step. Here's the parabola of x square is equal to y. Here's the straight line, sorry, y is equal to 1, and this is the point of x square. In the next step, x cube plus 1 in here in the question we have to first integrate it with respect to dx and then dy, but as we have now changed the order of integration, we are first integrating it with respect to dy and the dx, and so we have to change the limits also. Now the limits with respect to dy will become from this point to this point, which is from 0 to x square, and with respect to dx it will become from this point to this point, which is from 0 to 1. Step 2, here our integration starts 0 to 1, 0 x square. This is our integrated integration term, and dy dx we are first integrating it with respect to dy, so the resultant will be 0 x square y. We will keep this term as constant, so it will be x cube plus 1 dx. Now in the next step we are putting the limits in y, 0 1, and then it's x cube plus 1 into x square minus 0, the limits we have put, and dx. Now we have to integrate this term with respect to dx. I'm writing it in x cube plus 1, and that will become dx. Now we have to integrate this one. For this I'm using the simple substitution method. For this I'm taking this term to be equal to under root to be equal to t square, and I'm using differentiation on both of the sides. By using differentiation on this side we'll get 3x square, and since 1 is a constant term, so its differentiation will be 0, and we'll get here 2t, and I'm taking out the value of x square, which will come out to be 23 upon 3. Now when we use substitution method, we have to change these limits. When is equal to 0, I'm putting the value of x square as 0, t will come out to be 1, and when x is equal to 1, I'm putting the value of 1 here, t will come out to be under root 2. So now the limits have changed. Now they have become from 1 to root 2, and our question now in this step I'll substitute the value. In place of x square I'm writing 2t upon 3, and in place of this term under root x cube plus 1 I'm writing t, and now I'm integrating it with respect to dt. Here it is, and I am taking the constant term out of the integration, t square upon 2t square and dt, and solving it we'll get t3 upon 3 with the limits 1 to root 2. Here the limits are also there, so now it will 2 upon 9, 3 minus 1 into 3, and the final answer will come out to be as 2 under root 2 minus 1.